everyone, hope you guys are having a very good day. Today I received a mail from my friend. Let's see what she has for me. Okay, let's see what we had received today. A bell, symmetry, and a formula. Okay, if you guys are curious as much as me, to join us in this video. Data can be distributed or spread out in different ways. It can be more on the right, more on the left, or it can be all jumbled up. But still, there are many cases where the data tends to be around a central value with no bias left or right. With no bias at both sides, the curve gets close to a normal distribution, like this, with a bell curve. If the continuous random variable x is distributed normally, then the probability density function is as what we can see here. The mean and the variance for the normal distribution are denoted as mean and sigma square. Its distribution function can be obtained by integrating the probability density function of normal distribution that will give us this formula. If x is distributed normally with mean and variance, by substituting mean equals to 0 and variance equals to 1, we will get the formula. So, and a big so, by considering with what we had seen and learned just now, this function is called the density function of the standard normal distribution, and its distribution function is given as follows. So complicated it seems, isn't it, guys? Don't worry, we feel you so much. Hence, to keep it simple and just nice, we're going to give you something even easier. By referring to this formula, the letter Z refers to standard score or Z-score. The letter X refers to value of a normal random variable. The mean refers to the mean of a normal distribution, while the symbol sigma refers to the standard deviation of a normal distribution. So basically, guys, this is what we had seen in that mail. To further understanding on the topic, let's see the characteristic of the graph. The curve is in a beautiful bell shape and has a single peak at the center of the distribution. The arithmetic mean, mode, and median are equal. The total area under the curve is 1. Remember you guys, just 1. Half the area under the normal curve is to the right of the center point, and the other half is to the left of it. The graph is symmetrical about the mean. The curve is symptotic. It gets closer and closer to the x-axis but never actually touches it. It extends indefinitely in both directions. The location of a normal distribution is determined by the mean, and the dispersion of the distribution is determined by the standard deviation. As for the next, we will be seeing few information regarding the topic of approximation. Poisson distribution approximates the normal distribution when the mean is equal to lambda and it approaches infinity. This is explained as follows in the following formula. For normal to Poisson, we need to add or subtract 0.5 to or from the lower and upper bounds of the variable's value. This is due to the fact that the Poisson distribution is a discrete distribution, while the normal distribution is continuous. For this particular presentation, we are going to touch on 5 real-life situations. First of all, engineering, education, medical, sports, and last but not least, marketing. We can apply normal distribution in the field of engineering. Here, we can see how T affects the firing neutron activity distribution can be tested by repeating experiment with a different fixed T for each training process with the results given. Particularly with lower temperature, the neuron activity decreases, while higher temperature leads to intense neuron activity. So the previous mentioned equilibrium distribution can be reasonably considered as a similar real-life thermal equilibrium.
This graph shows us that it is normally distributed. Clearly, having a larger bell curve, which means more people at every level of play, and shifting the curve to the right, better players on average should both contribute to boosting the level of the national team.
We can use normal distribution in education field. We always use normal distribution to find the examination scores. For example, if we treat the raw scores of English, Maths, Science and so on as random variables, the total sum of the raw scores should be approximately normally distributed. We can apply normal distribution in marketing field. Whether it is weight, income, IQ, fitness level, and so on, data unvaryingly falls into a normal distribution when it is plotted. It has a lot of data around the middle and outliers at the both ends. We can also use normal distribution to find the human blood pressure in medical field. It can be approximated as a normal distribution between 85 and the standard deviation 20. A histogram of 1,000 observations and the normal curve is shown as follows. The histogram above allows us to understand a simple description of where most values are to be found. The standard normal distribution has a mean of 0 and a variance of 1 and is shown in the histogram.
Tables we will be using are the less than cumulative tables. They usually have the left tail of the distribution shaded and also have positive and negative parts. Let's look at an example. Scores on an exam are normally distributed with a mean of 65 and a standard deviation of 9. We want to find the percent of scores satisfying A, B, and C here. In A, we want the probability that X is less than 54. So for X equals 54, the corresponding Z-score is 54 minus 65 divided by 9, and that gives negative 1.2222 repeating. Since the Z-table is set up to handle only 2 decimal places, we round this to negative 1.22. We then go to the Z-table and look up the area. For Z equals negative 1.22, we go to the negative side of the table. Look for negative 1.2 in the first column and 0.02 at the top. The corresponding area here is 0.1112. That is, the area to the left of Z equals negative 1.22 is 0.1112. So on this normal curve, for Z equals negative 1.22, the area on the left here is 0.1112 as seen on the table. Therefore, the probability that X is less than 54 is the probability that Z is less than negative 1.22, which gives 0.1112 or 11.12%. In B, we want the probability that X is at least 80. In continuous distributions, like the normal distribution, there is no distinction between X is at least 80 and X is greater than 80. We apply the same approach in both cases. So for X equals 80, Z equals 80 minus 65 divided by 9, and that gives 1.67 to 2 decimal places. When we look that up in the Z table by checking 1.6 under 0.07, we find 0.9525. which is the area to the left of Z here. We then subtract it from 1 to obtain the greater than area, since the total area under the curve is 1. Therefore, the probability that x is at least 80 is the probability that z is greater than 1.67, which equals 1 minus 0.9525, giving 0.0475 or 4.75%. In C, we want the probability that x is between 70 and 86. For x equals 70, z equals 0.56. And for x equals 86, z equals 2.33. On the table, the area less than z equals 2.33 is 0.9901, while the area less than z equals 0.56 is 0.7123. When finding the area between two z values from the cumulative less than tables, we subtract the smaller area from the larger one. So the probability that x is between 70 and 86 is the probability that z is between 0.56 and 2.33. That is 0.9901 minus 0.7123, which gives 0.2778 or 27.78%. In summary, if you're finding a less than area using the cumulative less than tables, the area in the table is the answer. If you want a greater than area, then do 1 minus the area from the table. And if you want the area between two z values, then do bigger area, which will correspond to the larger z value, minus the smaller area, which will correspond to the smaller z value. Note that we do not subtract z values, we only subtract areas.
Practice makes perfect. It's better to have some exercises to further understand the calculation part.
For sure, dear, I got you. And that's what we're gonna see the next. Get ready, go. That's all from us for now. Thank you, sayonara, and see you again.